Hello everyone, today we will learn the fillet welding on the T-joint in the overhead position. In this lesson, you will learn the operational requirements for fillet welding on a T-joint in the overhead position, how to develop a welding plan, how to select welding parameters, how to weld qualified components meeting requirements of welding safety, cleanliness, environment, and the welding process, how to conduct a visual inspection of components according to the standards. This is the construction drawing of overhead position welding on a T-joint. We can see from the drawing that the material of the specimen is Q235. It consists of two steel plates, each 300 mm long, 150 mm wide, and 12 mm thick. The assembly angle is 90 degrees. The fillet welding on a T-joint in the overhead position is the most difficult operation compared to the other welding position on a T-joint. The welding is performed with welder above the arc and the welder head craned all the way back, which often leads to intense fatigue. The molten metal tends to drip down under the action of gravity and causes overlap or slag inclusion, resulting in an uneven weld. Therefore, if you want to weld high-quality welds in the overhead position, you need to practice a lot. Since the fillet weld size is 10 mm, we use multi-layer, multi-pass welding and weld one bead in the bottom layer, two beads in the filler layer, and three beads in the cover layer. In the following, we will learn the welding method and the process of this project according to the steps of preparation, assembly, welding of the bottom, filler, and the cover layers, as well as inspection. Before welding, we must prepare as follows. First, safety check. Ensure protective equipment is worn properly and in good condition. Clean up the work site. There must be no flammable and explosive articles. Second, welding machine preparation. Check whether the work cable, electro cable, and electro holder are properly installed and debug. Third, auxiliary tools preparation. Prepare tools such as grinder, welding hammer, chisels, files, steel brushes, steel rulers, and weld inspection rulers. Fourth, specimen preparation. Check the size of the specimens according to the drawing. Remove oil, grease, rust, and oxide from the within 20 mm on both sides of the parts to be welded until the metallic luster appears. This is the specimen after grinding. Fifth, welding materials preparation. According to the specimen material, we choose E5015 electrodes, diameter 3.2 mm, as they have better processing properties. The rods should be dried at 350 to 400 degrees before welding and keep warm for 1 to 2 hours. Use when needed. The next step is specimen assembly. First, pairing. Put the prepared pallet on the assembling platform and draw assembling position lines according to the construction drawing. Then follow the lines and assemble the plates into a T shape without any gap between. Tack welds are at the back ends of the fillet welds and are 10 to 15 mm long. Ensure the standing plate and the base plate intersect at a 90-degree angle. After tack welding, check assembly position, tack weld and vertically of plates. This is assembled specimen. Now, let's learn how to weld bottom layer. Fix assembled specimen on the platform with the weld parallel to the horizontal plane and in the welder's overhead position. Set the welding current at 110 to 120 ampere. During welding, hold the electrode at a 45-degree angle to both plates and at a 70 to 80-degree angle against the welding direction. Weave the electrode back and forth. Keep the arc down and pointing to the root. Ensure good fusion between the top angle and two plates. To avoid too much dropping from the molten pool, which causes concave weld, hold a short arc length and support the molten pool with arc thrust. The crater at the end of weld can be filled with arc extinguishing method. This is the schematic diagram of electrode angle when welding the bottom layer. After the bottom layer is completed, clean the weld bead with steel brush and welding hammer. This is a specimen with the bottom layer completed. Now, let's learn how to weld the filler layer. Set the welding current at 120 to 130 ampere. The filler layer has two beads. Weld the lower bead first and then the upper bead. When welding the lower bead, hold the electrode at a 60 to 65-degree angle to the standing plate and at a 70 to 80-degree angle against the welding direction. Point the arc to the lower fusion line of the bottom layer so that this bead covers 1/2 to 2/3 of weld bead in the bottom layer. Move the electrode straight or weave slightly. Keep a short arc length and slightly faster travel speed. When welding the upper bead, hold the electrode at a 60 to 65-degree angle to the standing plate and at a 70 to 80-degree angle against the welding direction. Point the arc to the upper fusion line of the bottom layer so that this bead covers 1/2 of the first bead. Transition from welding the lower bead to the upper should be smooth. Increase slightly the weave width of the electrode to avoid concave weld due to interruption. The weld surface should be flat and smooth without weld deviation and undercut, which layers a good foundation for the cover layer. This is schematic diagram of weld bead distribution and electrode angle and the filler layer. After the filler layer is completed, clean the weld bead with steel brush and welding hammer. This is the specimen with the filler layer completed. Now, let's proceed to the last step, welding the cover layer. Set the welding current at 110 to 120 ampere. The cover layer has 3 beads. The welding angle and the method are basically the same as those for welding the filler layer. When welding, the arc length must be short. Move the rod at the stable speed. The weave width and the speed of electrode should be uniform. These methods ensure good edge fusion and prevent defects such as undercut, lack of fusion, and overlap. The weld leg should be symmetrical and meet the size requirements. This is the schematic diagram of weld bead distribution and the electrode angle in the filling layer. After completing the cover layer, clean up the welding slag and spatter on the surface of specimen. This is a specimen with the covering layer completed. The key techniques of overhead precision welding on T-joint are as follows. First, small as keyword, use small diameter electrode and a small current. 15% lower than welding in the flat position. Second, the welder's position. The welder should choose a proper position which make it easier to weld and provides a good view of weld. After practice, we should organize tools and equipment, turn off the power, clean up the worksite, and write welding records. The surface of the specimen must be cleaned up without traces of processing, grinding, or repair. Then, inspection of improper fusion of weld, slag, surface porosity, crack, the width of weld, equal lengths, undercut, verticality, mechanical damage or arc abrasion, weld surface formation, etc. should be conducted by a welder themselves, fellow welder, and professionals according to rating standards. Now we have finished the lesson, and I'm sure that you have already got basic understanding of this welding operation. If you want to weld high-quality welds, you should be diligent in practice and keep exploring, reflecting, and summarizing during practice. That's all for today. Thank you.